Nearest distance classifier is a distance-based classifier that predicts the class of the sample that is nearest to it. So in order to do so, it needs to, for every evaluation sample, for each sample that we want to evaluate, we need to compute the distance between that sample and all the other samples that we have seen during training. Then we need to identify which of those training samples is the nearest, so which one has the smallest, the lowest distance. And then we see, okay, to which class does that sample, training sample, belongs to, and that is the class that we're going to assign to our evaluated sample. So imagine that this is the type of data that we see during training. We have circles and triangles, and then we receive a new sample that we want to evaluate. So as I said, the first thing we need to do is to calculate the distance between this new sample and all the samples that we see during training, identify the sample that is nearest to it, and then we can assign the class of that sample to the evaluated sample. So what are the variables involved in this classifier? So what are the hyperparameters and the parameters? In terms of hyperparameters, the only thing we need to specify beforehand is what type of distance metric we're going to use. And in terms of parameters, we don't need to do absolutely anything. And this is the biggest advantage, perhaps, although it's also a disadvantage, we will see it later, of these classifiers, which is we don't need to do anything during training. All we need to do is get the data and save it. So what are the characteristics of the nearest distance classifier? Well, it can generate very complex decision boundaries, very, very complex decision boundaries. In this case, we can even see that it can accommodate different regions or non-continuous regions for a single class. And it's easy to implement continuous learning. So the only thing we need to do is, well, if we now have new training data, we just need to add that data to our set of training data, and that's it. Automatically, the decision boundary will be optimized as a result. However, it's also very sensitive to all layers. In the example here, we have a triangle sample that is kind of like in just on its own, right? It's isolated. Is it reasonable to think that that region is characteristic of the triangle class, or is maybe just an outlier? So in terms of what are the benefits and the disadvantages of the distance-based classifier, well, the benefits is that they are very intuitive and straightforward concept. They are very easy to implement and to use. The training process is super fast, as we said earlier. You don't really need to do anything. And it can model very complex decision boundaries. However, they can be very expensive from a memory point of view. And this is because, as I said earlier, we need to save all the data, all the training data, because our model is defined by the training data. And this is okay if we have a small training data set, but if we have a very large training data set, potentially terabytes of data, then we need to keep, we need to save all of this in memory and carry it around whenever we want to move or deploy our model in different locations. As we have seen, it's very sensitive to all layers, and it can be inefficient during validation because we need to calculate all the distances. So the distance between the evaluated sample and all our training samples. And again, if we have a very large training data set, which generally speaking is a good thing in machine learning, in this scenario, it could be problematic because it can take a while.